Our project is Decision Rules, LERS, and Action Rule Discovery. This project is done by Group 10, consists of members myself, Shreya Shekhar, Ramanathan Shivaramakrishnan, Nidhi Srinath, Anat Sharma, Subham Shah, Neha Shrikant, Tejaswini Reddy, and Akshay Srinivasan. So the first topic which we are looking at is what is LERS? LERS stands for Learning from Example Based on Rough Sets. It allows us to generate rules which have a specific attribute on the right-hand side of the rule called as the decision attribute. LERS can be used for making business decisions or decisions in medical domain. For example, if our decision attribute is a class of lesions, that is a tumor, it could be either benign or malignant. Then we want to learn what decision, benign or malignant, by using the other attributes, and next make a decision about what to do with the tumor, like how to treat it, for instance. Until now, we could get any attribute on the right-hand side of the rule by using LERS. We only get decisions of the attribute we are interested in. LERS works based on the concept called as covering. Next, what is covering? For example, like P is a covering of R and S if P star is less than or equal to R star. In other words, P is a covering of R if P is a subset of R and we do not have a smaller set, which is a subset of R, which implies P is the smallest. For example, subset A is bigger than the subset A comma B, and A comma B is smaller than the subset A because A is more general than smaller than A comma B. In other words, A includes A comma B from the subset shown below. We need to first learn the steps to generate LERS rules. For example, take a set X where X is equal to X1, X2 up to X8. Classification attribute will be A and B, and the decision attribute will be C. Find coverings of A, B, C. Check if coverings of the classification attributes are the subset of covering decision attribute are marked them, like C, comma 0 is equal to X1, X3, C, comma 1 is equal to X2, X3, X4, C, comma 2 is equal to X5, X6, C, comma 3 subset is equal to X7, X8, and so on. This marking has to be done with respect to the table which is given, like where values for X, A, B, and C are given. Step 2, generate rules from the sets in the first loop. Certain rules are generated from marked set and possible rules are generated from unmarked set. Certain rules have confidence of 100, but possible rules have different confidence, which is less than 100. So certain rules like subset of A comma 1, which gives C comma 2. Subset of A comma 2 would give you C comma 3. B comma 0 can give you C comma 0. C comma 2 can give you C comma 3. A comma 0 and B comma 1 can give you C comma 1. Hence, possible rules would be A comma 0 gives C comma 1. Therefore, the confidence will be half. A comma 0 gives C comma 1 with confidence half. B comma 1 and C comma 1 will give you confidence half. B comma 1 will give you C comma 2 with confidence half. The next will be if there are unmarked sets in the first loop, then we go to a second loop. By combining the unmarked sets together, continue the process until there are no unmarked sets left. What is the confidence of certain rules? The confidence values indicates how reliable the rule is. The higher the value, the more likely the head item occurs in a group. If it is known that all the body items are contained in the group. Therefore, the confidence of a rule is the percentage equivalent of M by N, where the values are M and N.